Here is a question based on combinational circuits. The question is, a full adder circuit requires how many input and produce how many outputs. So basically, at first we have to know about the half adder. So half adder is a function, or half adder is a circuit which takes 2 bits of number. Here is 1 bit B1, here is 1 bit B0, and produce sum and carry. So basically, work of a half adder is to sum 2 bits of number, and now full adder is used to sum of 3 bits, and here also produce two output, one is sum and one is carry. So basically here full adder requires 3 inputs and produce 2 outputs. So option number C is correct. So 2 input 2 output, this is for half adder. 3 output is not generated in adder, and 1 output is not generated. So 3 inputs and 2 outputs for full adder. So option number C is correct. And it is a ISRO PYQ. So next question is based on logic gates. We have to find the output function y. Here is input A and B. Input A is sorted in 2 inputs for NAND gates. Here input A is connected, so here also get A, here we also get A. So basically NAND operation is done as if we give A and B, we get A and B bar. So here we also get A dot A bar. So basically A dot A means A, so we get A bar here. And similarly here we get B bar, and B dot B whole bar is equals to B bar. So here we get B bar. So here is also NAND gate, so we get A bar dot B bar. First input A here, and first input A is here, and second input B is here. So we get A dot B, as it is a NAND gate, so whole bar is okay. So by applying De Morgan theorems, we get A bar, we get input 1 bar plus input 2 bar. Here input 1 is A bar, input 2 is B bar. So double bar cancel. Here we get A and here we get B. So plus, here it is a plus operator, or it is a OR operator. So basically this function is work as a OR operator or gate. So option D is correct. So the next question is based on logic circuit. The question is, in a logic circuit, this is a logic circuit, if we provide so this is a logic circuit, this produce low output, low means 0, when both inputs are high. When both inputs are high, we get 0, or both inputs are low. So if both inputs are 0, this is one combination, so we get 0. If both input is 1, then we also get 0. So reason is, if we draw the truth table, it will be helpful for us. So now input A, input B, to input Y as an output. So you get 0, 0, 0, 1, 0, 1, 1. The question provides us when both input are low and when both input are high, we get 0 as an output, otherwise it is 1. So from this truth table, we found it as a truth table of XOR gate, as XOR produce low output when both input are same. Here both input are same, so we get 0. Here both input are same, here we get 0. Otherwise it produces 1. So this is basically XOR operation. So option number D is correct. So next question is also PYQ of ISRO 23. Question is the resulting logic circuit obtained when both inputs of NOR and NAND gates are connected together. So both inputs are connected together. It means if we have an input A and in the both terminal of the NAND and the NOR, both terminals here both terminals is connected through a one input. That is means both terminals are connected. So this question is provide this information. So what will be this circuit? Four options are mentioned, we have to find it. So basically, at first, for NOT gate, for NAND gate, we have to see that if we get A here, this is basically A, this is basically A. So NAND produce A dot A whole. As A dot A becomes A, it produces A. So when both the terminals are connected in inputs, it produces the complement of the input. So it is work as a NOT gate. And for NOR gate, here also we provide A, and here we get A, here we get A. So NOR gate produce A plus A whole. So we know that A plus A means A, and we get here also A. So this circuit also produce complement of input. So this is also work as a NOR gate. So option D is correct answer for this. So it is also PYQ of 23. This question is a truth table will need how many rows if there are n variables. So at first we take two variables. So here A and here B as input, Y as the output. So for two variables we write truth table as this 1 0 1 1. So basically for two variables we need 4 rows, and here we write truth table for three variables. Output here we get 0 0 0 0 0 1 0 1 0 0 1 1. Here now 1 0 0 1 0 1 1 1 0 1 1 1. So for three variables we get 8 rows in truth table. So we can write for as 2 to the power 2. Here 2 is the number of variables, and for three variables we get 8, and we can write 8 as a 2 to the power 3. Here 3 represent the number of variables. So for two variables we get 2 to the power 2, and for three variables we get 2 to the power 3. So in this question for n variables we get 2 to the power n number of rows. So option number C is correct for this question.